Hello, my name is Vegard. First off, I will start by showing the encoder component. This component controls many other components by sending out bits to tell the components what operation they should execute. The encoder gets its inputs from the microprogram memory and the data path. It also has a start input when everything is starting. Here in the encoder we can see that it got several inputs that it got from the data path and several outputs. The outputs will control different components when they are set to 1 and 0. I have just taken a small part of the code into my presentation because it is almost the same all the way. In the process here we can see that depending on the microoperations value, the outputs will be set to 1 and 0, and that will affect other components to either reset load as an example. Then we can move on to the address counter. The address counter increments the commands that are inside of the RAM, so that the RAM doesn't send out the same commands every time. It has a count state as an output and an increment, reset and clock as an input. We declare two internal signals and say that if reset is equal to 1, reg will be set to all zeros. If clock event occurs, reg will take the value of r next. Here you can see the components increments whenever increment is set to 1. Then the incremented value will later be sent to the RAM through the count state output. The last component I'll talk about is the bank register. This component sets whatever the inputs are to come out of the output if load is equal to 1. This is for whenever we want to update the adder with a new command. It gets its input from the RAM and sends the output to the adder. In the bank register we declare its inputs and outputs first, then we add two internal signals, and we code it so that it's two-segment coding. Here we have the process where we tell what happens in case a reset and clock event. Then we just say whenever load is equal to 1, the input will be put into R next and then sent to the output, and then the output C will take the value of whatever got sent into the component.